Okay, so in this video, we're going to learn a procedure, step-by-step procedure, and it's challenging. So you're going to need to write it all down, and this process is important, and the purpose of it is to learn how to solve polynomial equations. So polynomial equations can be third degree, fourth degree, fifth degree, all the way up to, infinite degree, okay? But we're only going to go as far as the fifth degree. We're not going to go any higher than x to the fifth power. Now this procedure for solving an equation is basically the same procedure if you're simply trying to factor a polynomial expression. So I'm going to show you how to do both of them at the same time, okay? So let's say we have a problem here. It says solve for all values of x. And we have this polynomial equation. It's a fifth power. One side is a fifth power polynomial. The other side also a fifth power polynomial. And so there could be up to 5 answers, up to 5 solutions. Now, there could be fewer than 5 solutions as well. Okay, and that's what we're gonna go through this process. So here's our problem: solve for all values of x. And we have a polynomial on the left, then we have equals, and we have a polynomial on the right. And I'm going to give you, it's a 5-step procedure. And really, at first, before we work through the example, I'm just going to give you the steps. And you should simply write the steps down into your notes. All right, so here's our first step. And really, you should just pause the video and write out this step. And I'm going to read it off. So the first step is we're going to cancel one side of the equation so that one side of the equation is equal to 0. And then on the other side of the equation is going to be a polynomial, and that's what we're going to use. We're going to use the polynomial that's on the other side. So what we're ultimately going to do here is we're going to cancel the right side of the equation so that this whole right side is equal to 0. So we're going to have to subtract x to the fifth, we're going to have to subtract 5x to the fourth, and we're going to have to subtract 7. And we're not going to do that right now. We're going to go through all the steps, and then we'll do all the steps in the example. All right, and then after we cancel one side of the equation so that one side is equal to 0, the next thing we're going to do is we're going to use the rational root theorem, which we learned in a previous lesson. Or in a previous video in this same lesson. We're going to use the rational root theorem. We're going to identify all of the candidates of possible rational roots. And that's the whole point of the rational root theorem, is the rational root theorem gives us a list of possible rational roots, and we call those possible roots candidates as roots. Only a few of them are actually going to be roots of the polynomial, but all of them are possible roots, and that's why we call them candidates, because a candidate is a possible. It's a possibility. All right, step 3, we're going to take this list of candidates that we got from step 2, and we're going to test them. We're going to test to see if each one of them is a root. It's like using the factor theorem. We're looking for a remainder of 0, okay? So we're going to test the candidates of possible roots. We're only going to test one at a time using synthetic division by putting one candidate at a time in the half box to see if that candidate results in a remainder of 0. So we're looking for a remainder of 0 for each individual candidate in the list of possible rational roots. Now there's 2 possibilities for each one. Either the remainder will be equal to 0 or the remainder will not be equal to 0. So if a candidate has a remainder that is not equal to 0, then it's not a factor. It's not a solution. Then what you're going to do is you're just going to cross that one, you're going to cross that candidate off the list and then move on and try the next one. Now this could result in having to cross off 5 or 6 of them, maybe even 9 or 10 of them. You got to keep trying until you get one where the remainder is equal to 0. So if you keep getting candidates that have a remainder that's not equal to 0, there's two possibilities. Either it's not one of the solutions, it's not a root. The other possibility is you may be making mistakes in your synthetic division. It would be a good idea to go back over all of your synthetic divisions to see if you made any mistakes. This is why it's very important to do it on paper, and don't erase each one. Do one and leave it, and then move on to another part of the paper and do another one. If you erase them, then you won't be able to see if you were making any mistakes. Now make sure you're writing these steps down in your notes. If you have to pause the video and write down these steps, then go ahead and do that. You've got to have these in your notes so that you're able to practice some of the problems. Now, if a candidate does get a remainder equal to 0, then that number, that candidate, it is a root. So what you're going to do is you're going to start a list, and you're going to list that candidate as a root, which means it's a solution to the equation. And then in addition to listing that particular candidate as a root, what you're going to do is you're going to go to the bottom line of your synthetic division, the one that has a remainder of 0. You're going to write out that bottom line quotient as a reduced polynomial. So you're going to make the polynomial 1 power smaller. So if you started with a 5th power polynomial, you're going to write out the new reduced polynomial as a 4th power polynomial. And this is actually going to make the process easier and easier and easier. Also, in addition to taking the bottom line quotient and writing it out as a new polynomial, which we're going to call the reduced polynomial, you're also going to record parenthesis x minus and whatever candidate you just tested. You're going to record that as a factor of the polynomial. Like I said, we're learning two things at the same time. We're learning how to solve a polynomial equation, but we're also learning how to factor the polynomial. And this is where we get our factors. What do I mean by record x minus candidate? Well, let's say that the candidate in the half box is -5. And when doing -5 in the half box, you wind up with a remainder of 0. Well, that means you're going to put -5 in your list of roots, and then you're going to do parenthesis x plus 5, because this is x minus -5. X minus -5 is x plus 5. You're going to put x plus 5 in your list of factors. So you're making 3 lists here. One list of candidates that you're testing, one list of roots that are the solutions for the equation, and the third list you're making is a list of factors of the polynomial. And then after listing the factor of the polynomial, you're then going to go on to step 4. Now there is an exception. Note this, write this down. If the reduced polynomial is quadratic, that means it's x to the 2nd power, right here. We're going back to, you're writing out the bottom line quotient as a reduced polynomial. If that reduced polynomial is actually quadratic, then you're not going to go on to step 4. You're actually going to skip ahead to step 5. All right, so let's say that your bottom line reduced polynomial, let's say that it's not a quadratic. So you're going on to step 4. All right, what should we do in step 4? Well, you just found one of the roots. In step 3, you got a remainder of 0. You found one of the roots, which is one of the solutions, and you've identified one of the factors of the polynomial. And you've also written a reduced polynomial, and that reduced polynomial is what we're going to work with next. Now what you're going to do is you're going to test the same candidate again. So if you found that -5 in the half box resulted in a remainder of 0, then on the reduced polynomial, so now you're not going to use the original top line that you used. You're now going to use one less number from the bottom line of your synthetic division. You're going to use those numbers and test the same candidate again. Why would you do that? Well, you might actually get a remainder of 0 again. It's possible that x equals -5 is actually a solution twice. And I know that sounds totally weird for the same number to be a solution twice, but with polynomials, that is possible. Now, the important thing isn't that it's a solution twice. The important thing is that if you get a remainder of 0 again, the important thing is that the factor actually shows up twice. That means that that particular factor has a multiplicity of 2 because there are 2 of them. But you'll only be able to find out if it has a multiplicity of 2 if you test it a second time, and maybe even a third time. Now, when you test that same candidate a second time, if the remainder is not 0, then you're just going to move on to the next candidate on the list. But if the remainder is 0 again, then you're going to list it as a root again. You're going to write out the new bottom line quotient as another reduced polynomial, and then you're going to record x minus that candidate as a factor of the polynomial. If it's the same one, then you're going to wind up with the same factor twice, and that just means that the multiplicity is 2. On the other hand, if the remainder is not 0 and you move on to the next candidate, what you're going to do is you're going to keep moving on to the next candidate as long as the remainder is not 0. Eventually, if you come across a candidate where the remainder is 0 on another candidate, then what you're going to do is for that other candidate, you're going to list it as a root, just like you did with the first one. Then you're going to write out the bottom line quotient from the synthetic division as a new reduced polynomial. So your polynomial is going to get reduced and then reduced again and then reduced again until it gets smaller and smaller and smaller. That's how we find the solutions, is by making the polynomial smaller and smaller and smaller through synthetic division. And what you're going to do is you're also going to, once again, you're going to record the next candidate as a factor, x minus the candidate. So let's say that after trying -5, you don't get a remainder of 0. Let's say next time you try x equals 8. And when you do x equals 8, you wind up with a remainder of 0. Well, then you're going to list 8 as a root. You're going to write out, you're going to have a new bottom line numbers here. You're going to write that out as a new reduced polynomial. And then you're going to record x minus 8 as a factor of the polynomial. X minus 8 is going to be one of your factors. Then what are you going to do? Then you're going to repeat step 4. You're going to go back up here and you're going to test the same candidate again. That means you're going to test 8 again on the new reduced polynomial. And you're going to see if 8 results in a remainder of 0, or excuse me, a remainder of 0 or a remainder not equal 0. And if you get a remainder not equal 0, you're going to move on to the next number and the next number until you run out of candidates. Or you're going to repeat step 4 until the bottom line quotient as it gets reduced and reduced is only 3 numbers plus your r equals 0. So be careful. Watch for the synthetic division. And when you're down to 3 numbers on the bottom line, you're actually done with step 4. When you get down to 3 numbers on the bottom line, that means that the reduced polynomial is quadratic. And just like in step 3, we said that once it becomes quadratic, we skip over to step 5, or in this case, we just move on to step 5. All right, once you get to step 5, what you're going to do is you now have a quadratic, and what we're going to do now is solve the remaining quadratic in one of 2 ways, either by factoring, if it is factorable, or if it's not factorable, then we're just going to use the quadratic formula. And remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, there are 3 possibilities. 2 possibilities if you use the quadratic formula. One possibility with the quadratic formula is you wind up with the square root of a negative number, like the square root of negative 83. Okay, you know that if you have the square root of a negative number, that means that there are no real solutions. So if there are no real solutions, then there are no more roots. That means your list of roots are all of the answers, and then that means your list of roots is done. But there is one more factor. This quadratic expression that you have found that you're doing in step 5, it actually is a factor of the polynomial, and you'll write the quadratic as the final factor. So you might have something like, x plus 3 times x plus 5, in your list of factors, times x minus 8, and then maybe something like x squared plus 7. So you could wind up having a quadratic as your final factor, but this quadratic, x squared plus 7, it doesn't have any roots. So you would only have negative 3 and negative 5 and 8 as your roots. Now the second possibility, if it's not factorable, is that it has real solutions, but they're irrational. So they're not rational roots. They're irrational roots, and there will be 2 of them. If you do the quadratic formula and you wind up with real solutions and they're irrational, well, then just add them to the list of roots. But you're not going to have 2 new factors. You're just going to use the quadratic that you started with as the factor, just like you did in this possibility up here. Okay, and I'll show you an example of that. Now suppose that the quadratic that you came into step 5 with, suppose that it is factorable. Okay, well then what you're going to do is you're going to factor it into 2 factors. For example, let's say that you have x squared minus 7x plus 10. That means that this is factorable into x minus 2 and x minus 5. And so what you're going to do is you're going to take x minus 2 and x minus 5 separately. You're going to set each factor, each one of the 2 factors, equal to 0. So you'll set x minus 2 equal to 0 and x minus 5 equal to 0. And then for each one, you will solve for the last rational roots, which in this case would be 2 and 5. Now, once you're done with all these steps, you will have gone through not necessarily all of your candidates, but you've gone through enough of them. Any candidates that are left over after this, you can ignore them. But you now have a list of roots of this polynomial. And you also have a list of factors. And I'm going to tell you what to do with both of those lists. The list of roots that you now have, those are the solutions for x. Now, if any of them are duplicates, if the same number shows up more than once, you can ignore any duplicate roots. You can just ignore them. So if your list of roots is like, 1, and then 3, and then 3, and then negative 4, and then negative 4, if that's your list of roots, you only need 1, 3, and negative 4. You can ignore the duplicates. Now, the list of factors that you have is the factor form of the polynomial. But in this case, you're going to keep the duplicate factors, okay? If you have duplicate factors, that just tells you the multiplicity. For example, if you have x plus 1, and another x plus 1, and another x plus 1, and then you have like an x minus 5, and then you have like a 3x minus 4, okay? Then this is the factorization of your polynomial. And having 3x plus 1s just means that you have x plus 1 to the 3rd power, and then an x minus 5, and then a 3x minus 4. Now, because some of the candidates can be fractions and take the form p over q, it's possible that one of your factors is x minus a fraction. So for example, you might have x minus 5 over 4 as one of your factors. Well, you're not going to keep that. You have to change it, okay? if this happens, then look at the denominator. Do you see that 4? That means that in one of your other factors, there's actually a 4 that is a factor that can be factored out. For example, one of your other factors may be something like 4x squared minus 12, okay? Well, let's say plus 12, okay? And in this factor, you can actually factor out the 4. So you can see it says if one of your factors is x minus a fraction, then factor q, that's the denominator, out of another factor. So you're going to look at your other factor and factor out the 4. So we're going to factor out a 4, and 4x squared divided by 4 is just x squared, and plus 12 divided by 4 is plus 3. So then you're going to take that 4 and you're going to remove it. You're going to leave the x squared plus 3, and you're going to take that 4 and you're going to multiply it by this fractional factor. And it's going to look like this. 4 times x minus 5 over 4. When you do that, you're going to do 4 times x, and that's going to be 4x. And then 4 times negative 5 over 4 is actually just going to become minus 5. And so then one of your factors is actually going to be 4x minus 5. And this other factor, after the 4 is gone, will just be x squared plus 3. Okay? All right. Now what we're going to do is I'm going to go ahead and end this video. And in the next video, we're going to work through the original example that we had at the beginning of this video.